Hey everybody, Mr. Murray here, Mr. Murray's Math Land, and we're sketching some sinusoidal functions again today, but this time we are taking a look at what are called phase shifts, a phase shift. And a phase shift is just another word for a horizontal shift. When you do a horizontal shift or horizontal translation, when you do a horizontal shift on a trig graph, they call it a phase shift. But it's no different than when you take, say, a parabola and you move it left or right. That's a horizontal shift. That's a phase shift of its own. And so when you get that, you may recall when you have functions and you translate them horizontally, that's when you add or subtract a constant to the x quantity, on the inside of the function. So hopefully you're keeping all those old school rules straight about what moves graphs up and down, what makes them reflect over the x-axis, and it's all the same stuff. But just when you do them to trig graphs, it makes it a little more complicated because they're a little newer and they got a lot of little details going on. So here we go. We're going to take a look, and these graphs have everything in it: amplitude, period changes, midline equations. So let's take a look here at this one. If you can handle these, you can pretty much handle anything. So we're going to sketch one cycle of this, and we're going to find the 5 key points because those are where your maxes and mins and your middle of the graph lie. So let's take a look and put this all together. Okay, so first we are graphing a positive cosine. It's always nice to kind of have a plan of attack here. A positive cosine looks like that, right? Like that, kind of like that cow's udder, right? That half of a crest and one complete trough, and then ends with a half crest. Our amplitude, that's usually pretty easy. That's 3. Our midline, that's our vertical translation. That is y equals -2. That's that constant that's added to the end there, or subtracted in this case. The period, these are all the same rules we've used before here. The period is 2 pi divided by whatever is being multiplied to x. Now, just be careful. I know you see x right here and you see a coefficient of 1, so maybe you think the period has not been changed, but there's a 2 right here which is being multiplied to that x. So it just happens to be in factored form, but the fact remains that x is still being multiplied by 2, which is going to cause that period change. So just watch out for that. So we get the period is pi, and the increment, the distance between those 5 key points, is always whatever that period is, so pi in this case, and divided up into 4 equal regions. So each one is going to be pi over 4 units apart. Okay, now it's just about getting what that first x value is, what x1 is. And the easiest way is to, I think, if you're ever in doubt, just grab the entire inside quantity and set it equal to 0 and solve. Now I think you can see that, and by the way, if you are thinking, could I grab that 2 that's also with it? Yes, but it's factored out, so as soon as you grab it, in fact, if I do, just since this is a first problem here, if you grab that 2 right along with that x plus pi over 4, the first thing you can do is divide both sides by 2, so you really get to this anyway. So x plus pi over 4 equals 0. So that's what I was going to say. Start off just by grabbing that inner quantity. And of course, when you subtract, you get x equals -pi over 4. That means the entire graph has been shifted to the left pi over 4 units. And that is our x1. Instead of being at 0, a starting point, we are starting our graph at -pi over 4. And now the other points are going to come right along after that. And they are all this increment distance away. So add pi over 4 and you get to the next key point. So -pi over 4 plus pi over 4 is 0. Add it again to 0 and you get pi over 4. Add it again and you get 2 pi over 4. Add it again and you get 3 pi over 4. Now 2 pi over 4 actually reduces to pi over 2. I just kept it as a common denominator, you know, until the end. But there you go. There are your 5 key points. No big deal here. If I were using graph paper, I would really be careful about the scale I chose. But as it is, it's a sketch, and I'm going to try to roughly draw it to somewhat to scale so it's evenly spaced. So for example, if that is my first key point of negative pi over 4, and here's 0, my second key point, my x3 is at positive pi over 4, so it should be about the same distance away. And the 5 key points should all be about that, because every one of them is pi over 4 units. So there we go. There's my 5 key points, roughly. Negative pi over 4, you don't have to label 0, it's the origin. If you want to, of course you can. That's pi over 4, that's pi over 2. And this final point is 3 pi over 4. On the y-axis, we have a midline of negative 2. So I certainly need to go down to negative 2. And my amplitude is 3, so I'm going to have to go 3 units below that. So 3 units below negative 2 is down to negative 5. Negative 3, negative 4, negative 5. And 3 units above that negative 2. And so negative 1, negative 2, negative 3, negative 4, negative 5. And 3 units above that is going to be as high as positive 1. So, and there we go. Our midline, like I said, is going to be at y equals negative 2. And now here we go, our 5 key points here. Remember, on the cosine graph, here's where the 5 key points are. On all of them, they alternate being on the midline or being at a max or a min. And with the cosine, the first one is going to be above the midline. So at negative pi over 4, at my x1, I'm going to be above the midline by an amplitude of 3. So at that maximum value of 1. And my second key point is 0, and that's going to be right on the midline, 0, negative 2. Pi over 4 is going to be at the minimum, you know, off the midline by an amplitude of 3. Pi over 2 is going to be back on the midline. And 3 pi over 4 is going to be back off the midline by an amplitude of 3 above it. There we go. There's our key points. And just try to draw a decent graph there that will, you know, try to show that curvature. See those waves. And there we go. Not so bad, right? And that had everything in it, like I said. So if you can handle that, you're in pretty good shape. So we'll do one more here, just so you can see the difference here. And when we look at it in a second, where it's going to differ is right here with this inner quantity. This one was in factored form. Note that 2 was factored out. So it didn't really affect this, you know, this finding x1, because I could divide by 2 right off the bat and get rid of it. But check out this next one here, that the inner quantity also has, you know, a constant added or subtracted to the inside. But notice this pi over 2, this coefficient, has not been factored out. So just watch out for that. That's gonna play with it a little bit. So what are we doing here? We are graphing negative sine. Let's go through the whole routine here, putting it all together here. Not easy by any stretch, but once you get the hang of it, you can handle anything. So a negative sine cycle starts with a trough, ends with a crest, you know, starts with a valley, ends with a hill. There's the 5 key points on it. Our amplitude is 5. That's the absolute value of the coefficient. Our midline, the middle of the graph, is at y equals 1. It's the constant on the end. Our period is 2 pi divided by that coefficient of pi over 2. So 2 pi divided by pi over 2, maybe you've gotten good at doing these in your head. Maybe you have to always, you know, take this step and write it out. That means 2 pi times 2 over pi, the reciprocal there, which is kind of nice. Those pi's cancel. And your period is 4. Nice. Which means your increment is going to be that period of 4 divided by 4, which really works out nice because now they are just 1 unit apart. Okay, so I know that they are, each key point is 1 unit apart. I know the total period is 4, but let's find when does that cycle start. Where do we start this negative sine cycle at? So here's where we're going to grab this whole inside. This is what I think is the easiest way to do it. I'm going to grab that whole inside, and you see this time that pi over 2 comes right along with the x since it's not factored out. And when I set that equal to 0, I'm going to subtract pi over 4 first. So I have pi over 2x equals negative pi over 4. Then I'm going to multiply by 2 over pi to solve for x. I'm going to multiply by that reciprocal, or in other words, dividing by pi over 2, if you will. And just be careful here. Those pi's are going to cancel, and you're going to get negative 2/4 or negative 1/2. And that is your first key point. This graph has been shifted 1/2 unit to the left. So just the same strategy, you grab the inside and you set it equal to 0. But because it wasn't in factored form, you didn't just get, some people want to look and say, oh, I see plus pi over 4. Maybe that means it's negative pi over 4. Not quite, because it wasn't in factored form. So just be careful with that. Set the inside equal to 0 and solve. Easiest way. So now I got the first key point is negative 1/2. So the next key point, I'm going to use my increment of 1. Right, I'm just going to add 1, and so that's going to put me at positive 1/2. So x3 will be add 1 again, and you'll get 1.5, 1.5. I don't know if you want to use decimals or fractions, whatever. Add 1 again, you get 2.5. Add 1 again, and you get 3.5. Notice that total distance from x1 to x5 is a distance of 4. That is the full period, as it should be. Okay, so our scale would be a half unit, I guess. Well, let's see here. If I call that negative 0.5, then this would have to be about positive 0.5. And then I'd have to go every, I don't know if you'd have enough room here to do that. But let's see if, and keep in mind, if that is 1 unit, then you need to be roughly spaced out before you put your third one, right? So I actually don't know if I left myself enough room, which is why sometimes this is easier with graph paper, because it forces you to be good about that. But we're going to just eyeball it there. There's about negative 1/2. There's about positive 1/2. A positive 1 would be about that distance away. I'm going to skip that, and there would be about 1.5, and about that same distance away would be 2.5, and then right about there would be 3.5. So there we go. Roughly to scale. We're not using graph paper. It doesn't have to be perfect. Our midline is going to be 1. So, and our amplitude is 5. So just a little quick planning here. If my midline is 1 and my amplitude is 5, that means I need to go as high as 6. So 1, 2, 3, 4, 5, 6. And I need to go as low as negative 4. So that would be 5 units below positive 1, right? So 1 minus 5 is negative 4. So negative 1, negative 2, negative 3, negative 4. Again, these things are not perfect. There's my midline of 1. And maybe I'll label after I draw the graph. That way I'll know, I can kind of label around the graph I end up drawing. But with the sine graph, remember the first point is right on the midline. So at negative 1/2, my point is going to be right on the midline. So negative 1/2, comma 1. At my second key point of 1/2, I'm going to be at my minimum with the negative sine cycle. So that would be down at negative 4. x3, I'm going to be back on the midline. x4, I'm going to be above the midline by an amplitude of 5. So up there at 6, And then x5, I'm back on the midline, and there's your one complete cycle. Right, you try to draw a decent wave. That's sinusoidal wave there. Okay, and now we're just going to label. So that's 6. If you want to label all these, that's fine too. But really, as long as I like to see the maximum minimum y values, so that should be what's really obvious. I should be able to see those, and I should be able to see the x values where they line up. So that's 3.5, that's 2.5, 1.5, 1/2 or 0.5, and this is negative 0.5 there. So it's got a little congested in there. No big deal. Okay, but there's our graph, and we saw two examples, a sine, a cosine, both with phase shifts. One of them had it factored form, and one had it non-factored, so you'll run into either one. So hopefully you saw enough variety just in these two examples that if you have a little trouble, it could get you over the hump. So as always, if you have questions, just ask. I'm happy to help. Have a good day.